let's talk about why Mars is red. You might think Mars, because it has sand, it is red. It is not sand. It is actually iron oxide dust. Iron bond up in Mars rocks have some point reacted with liquid water or water and oxygen in the air, similar to how rust formed on Earth. Over billions of years, this rusty material, iron oxide, has been broken down into a dust and spreads all around the planet by winds. And this is one of the few cases and few evidence points we have that Mars was once habitable, as you need water and oxygen, and water and oxygen usually happens when a planet is habitable. But the reason Mars isn't habitable anymore is because it lost its protective magnetic field. Since of its size. Due to its smaller size, its core froze, causing its magnetic field to drastically dissipate. And while Mars does have an atmosphere containing methane, carbon dioxide, and etc., it isn't big enough to host a bigger atmosphere like Earth. And even if you terraform it, it won't work. But that's differentiating from the point. Let's talk more about this iron oxide. Martian dust is primarily composed of fine-grained ferrihydrites, which is Fe3HO8 N4H2O, a hydrated iron oxide mixed with basalt rocks and sulfur-rich components. The iron-rich dust gives the planet its red coloring, existing in poorly crystalline state as a coating on the surface particles. Recent studies suggest this hydrated form is more abundant than previously thought, indicating an ancient wet climate. And before we get into the other stuff, we also have other data from ESA's other mission, Mars Express. And we're eventually going to get more data from their next mission, the Rosalind Franklin Lander, which is a rover mission and will be the first European rover mission. So I hope you stay tuned for that. And to prove all this, a case of study reference point, a 2025 study utilizing data from the Mars mission, including the European Space Agency's Roscosmos Trace Gas Orbiter, TGO, suggests that ferrihydrite, a water-rich iron mineral, like I said before, is a primary responsible for Mars' red color rather than just a dry hematite. This mineral form is cold, wet environment, indicating that Mars likely had a significant surface water and more habitable wet climate than previously assumed. This is just my evidence. I looked it up, and yeah. I hope you love this video. And there's a bit of mistakes in there, but who cares? But I hope you enjoyed this video. And bye-bye!